All right, let's talk about various transformations of functions. So here I've graphed for you already f of x equals x squared, plotted a few points and made a graph. Let's consider this function. G of x equals x squared plus 3. Okay, so notice I've taken the same function, x squared, but I've added 3 out here on the end. So g of x equals x squared plus 3. Let's make a graph of g. Okay, so let's plot some points. So the initial value, say g of 0, I would plug in 0, and I get 3. So g of 0 is 3, so I would plot the point 0, 1, 2, 3. A g of 1. So if I put a 1 in, I get 1 squared plus 3. Would be 1 plus 3 or 4. So if I plug in a 1, I get a 4. Let's do g of negative 1. Okay, so if I plug in negative 1 to this function, I'll get a negative 1 squared. Make sure you remember the parentheses. Plus 3. Negative 1 squared is 1. 1 plus 3 is 4. So g of negative 1 would be 4. Okay, so notice when I plugged in 0 to the blue g function, I got a 3. When I plugged 0 into the black function, f, I got a 0. So notice that this dot corresponds with this point. And when I plugged a 1 into the f function, or the black function, I got a 1. When I plugged a 1 into the blue function, I got a 4. So notice that this point got shifted up 3. This point got shifted up 3. Let's do some more. So if I plug a 2 into the blue function, into g, I'll get 2 squared is 4, plus 3 is 7. So 5, 6, 7. If I plug in a negative 2 to the blue function, I get 4 plus 3 or 7. So notice again on the black function, when I plugged in a 2, I got a 4. And when I plugged in a 2 to the blue function, I got a 7. So this point corresponds with this point, and it got shifted up 3. Let's plug a 3 into the blue function. So 3 squared is 9, plus 3 is 12. So I plug in a 3, and I get a 12. If I plug in negative 3, I'll get 12. And so notice here that this point, the point 3, 9 from the black function, corresponds with the point 3, 12 from the blue function. So this point got shifted up 12. Any point on this black graph, say this point here, if I plug the same x value into the blue function, I would get a point 3 units higher. So this 3 out here, if I add that 3 to the function, it's going to take the original x squared function and shift it up 3 units. So every point on the graph goes up 3. So my new graph would look like that. Okay, let's try another example. So let's do h. So h of x is equal to x squared minus 1. I don't know if you guys can see that. Maybe we should do blue again. Let's do h of x equals x squared minus 1. Okay, so if I want to graph this new function h, let's find the initial value. I'll plug in 0 for x, and I'll get a negative 1. If I plug in a 1 for my x, I'll get 1 minus 1 is 0. Plug in a negative 1 for x. Negative 1 squared is 1. 1 minus 1 is 0. If I plug in a 2, I get 4 minus 1 is 3. So that would be here. If I plug in a negative 2, I get 4 minus 1 is 3. That's here. If I plug in a 3 to this new function, I get 8. So that goes here. And negative 3, I will get an 8. Goes here. And you see I get this function. So this is H. This one is G. Alright, so notice that this original point 0, 0 got shifted down 1. This point 1, 1 got shifted down 1 to 1, 0. This point at 2, 4 got shifted down 1 to be 2, 3. This point that was at 3, 9 got shifted down 1 to be 3, 8, and so on. So notice that this minus 1 out here on the end of the function shifted the original function, x squared, down 1 unit. Alright, so again I have the original black function, f of x equals x squared, graphed for you. Let's graph this new function g. And notice that the minus 3 is inside of the parentheses, so x minus 3 all squared. Let's find g of 0. So if I plug 0 into this function, I'll have 0 minus 3 is negative 3 squared. And negative 3 squared would be 9. Okay, so if I plug in 0, I get the point 9. But notice that we squared negative 3. In the original function, if I plug in negative 3 squared, I get a 9. Okay, let's do another. Let's do g of 1. So if I plug 1 in here, 1 minus 3 is negative 2 squared, which is 4. So if I plug in a 1, I get a 4. Okay. Notice that when I plug a 1 into this function, well, I'm doing the same thing as plugging a negative 2 into the original function. If I put a negative 2 here, negative 2 squared is 4. And let's do another. So I'm going to plug a 2 in. 2 minus 3 is negative 1 squared, which would be 1. So I plug in a 2, and I get 1. All right, notice that when I plug in a 2 to the g function, it's the same thing as plugging a negative 1 into the original function. So this point here that goes with the negative 1 on the black function is the same as plugging a 2 into the blue function. So this point corresponds with this point. This point corresponds with this point, and this point corresponds with this point. Let's do another. Let's plug a 3 in. 3 minus 3 is 0. 0 squared is 0. So I'll plug in a 3, and I get 0. Notice that plugging a 3 into the blue function is the same thing as plugging 0 into the black function. So this point, for plugging 0 into the black function, corresponds with this point. Notice that I shifted it to the right 3 spots. These points corresponded. I shifted it to the right 3. These points corresponded. I shifted it right 3 spaces. These points corresponded. I shifted this point right 3 spaces. Let's do another. Let's plug in 4. 4 minus 3 is 1. 1 squared is 1. So plugging a 4 into the blue function is the same thing as plugging a 1 into the black function. So this point, plugging a 1 into the black function, should correspond with this point. So I should move it over 1, 2, 3 spots. And sure enough, 4, 1. Let's do one last one, or let's make a couple more. Let's plug in a 5. 5 minus 3 is 2. 2 squared is 4. So I have 5, 4. Notice that plugging a 5 into the blue function is the same thing as plugging a 2 into the black function. So the point 2, 4 on the black function should correspond with the point 5, 4 on the blue function. One last example, plug in a 6. 6 minus 3 is 3. 3 squared is 9. So, plugging a 6 into the blue function should be the same thing as plugging a 3 into the black function. So when I plugged a 3 into the black function, I got 3, 9. So plugging a 6 into the blue function, I should get a 6, 9. And sure enough, that's what we got. Let's graph this. So we can see that every point on the black function got shifted right 3 spaces. So this minus 3 caused every point on the original function to shift right 3. Notice that it's opposite. Minus 3 caused the function, the original function, the black function, to shift right 3 spaces. All right, let's do another example. Let's do h of x equals x plus 1 squared. So let's make a conjecture of what this plus 1 inside the parentheses might do to the original black function. So if minus 3 shifted the original function right 3 spaces, plus 1 might shift the original function left 1 space. Let's see if that really happens. So let's plug in some points. Let's do h of 0, and let's see what happens. So if I put 0 in here, 0 plus 1 is 1. I get 1 squared, which is 1. So plug in a 0, we get a 1. Notice that plugging a 0 into the blue function is the same thing as plugging 1 into the black function. So this point 1, 1 on the black function corresponds with point 0, 1 on the blue function. All right, let's do another. Let's do h of 1. 1 plus 1 is 2, and 2 squared is 4. So plugging a 1 into the blue function is the same thing as plugging a 2 into the black function. So the point 2, 4 on the black function should correspond with the point 1, 4 on the blue function. All right, let's do another. h of 2. 2 plus 1 is 3. 3 squared is 9. So the point 2, 9. Okay. Plugging a 2 into the blue function is the same thing as plugging a 3 into the black function. So the point 3, 9 should correspond with the point 3, 9 on the black function should correspond with the point 2, 9 on the blue function. All right, let's do h of negative 1. So if I plug in negative 1 into the blue function, negative 1 plus 1 is 0, 0 squared. So plugging a negative 1 into the blue function is the same thing as plugging 0 into the black function. So on the black function, point 0, 0 should correspond with negative 1, 0 on the blue function. Let's do just a couple more. H of negative 2 and h of negative 3. So if I plug in negative 2, negative 2 plus 1 is negative 1. Remember your parentheses. Squared is 1. And negative 3 plus 1 is negative 2. Squared is 4. So h of negative 2 would be 1. H of negative 3 would be 4. Let's graph this. All right, so notice this point got shifted left 1. This point got shifted left 1. This point left 1. This point left 1. This point went left 1. This point went left 1. And so with this one. So every point on the original black graph got shifted left 1 space. So the plus 1 caused the original function to shift left 1 space. So it's kind of opposite. Okay, let's look at another interesting example. So again, I've graphed x squared for you. Let's graph g of x equals 2 times x squared. Okay, so let's just plug in some points. Let's find g of 0. That'll be 2 times 0 squared. So 2 times 0 squared, order of operations, I do exponents first. 0 squared is 0. 2 times 0 is 0. So I get this point. Let's plug in negative 1. That'll be 2 times negative 1 squared. If I square negative 1, I'll get 1. And then 2 times 1 is 2. Okay, so plug in negative 1. And I got a 2. Notice that plugging negative 1 into the blue function is the same thing as plugging negative 1 into the original function and then multiplying that by 2. So if I plug negative 1 in to the original function, I get 1, but then I have to multiply by 2. So plug negative 1 into the original function, I got a 1. But this time, when I plug negative 1 into the blue function, I have to take this value of 1 and multiply it by 2. So I get 2. All right. Plug in a negative 2. It'll be 2 times negative 2 squared. Negative 2 squared is 4. 2 times 4 is 8. So I plug in a negative 2, and I get 8. And notice that plugging negative 2 into the blue function is the same thing as plugging negative 2 into the original function and then multiplying your answer by 2. So when I plug negative 2 into the original function, I got 4. But now I'm going to multiply that 4 by 2 and get an 8. I don't have it over here, but let's plug in negative 3. If I put a negative 3 into the blue function, I get negative 3 squared is 9. So corresponding with this point, and then multiply by 2 and get an 18. So it's way up there off my board somewhere, so we won't plot that one. All right, if I put in a 1, right, 2 times 1 squared. 1 squared is 1, so I get a 2. So here, notice that plugging a 1 into the blue function is the same thing as plugging a 1 into the black function and then multiplying your answer by 2. My g of 2 is 2 times 2 squared. 2 squared is 4. 2 times 4 is 8. And I get 8. Notice that plugging a 2 into the blue function is the same thing as plugging 2 into the original function and then multiplying your answer by 2. So when I plug 2 into the original function, I got 4. Plug 2 into the blue function, I get 4 times 2 is 8. So every point on the black graph, on the original graph, the y value gets multiplied by 2. So here, the y value is 1, multiply that by 2, and I get 2. Here, the y value is 4, multiply that by 2, and I get 8. On this one, the y value is 9, multiply that by 2, and I get 18. So I would have the point 3, 18. So if we graph that, looks like that. So it kind of made the graph skinnier and steeper. But the main thing to notice is that the y value of this original point got multiplied by 2. The y value of this original point got multiplied by 2, gave me a new value. If I could graph it here, the y value of this is 9. If I multiply by 2, I would get 18, so I would have the point 3, 18. So every point on the original graph, the y value gets multiplied by 2, and that gives you the y value of a point on your new graph. All right, here's another example. H of x equals 1/2 x squared. So let's plug in -3. I will get 1/2 times -3 squared. Remember your parentheses. -3 squared is 9. 1/2 times 9 is 4.5. So if I plug in -3, I'll get 4.5. Notice that plugging -3 into the blue function is the same thing as plugging -3 into the black function, squaring it, and then multiplying your y value by 1/2. So when I plug -3 into the black function, I got a 9. Y value is 9. Multiply 9 by 1/2, and I get a 4.
Mr. Boss, call 1-200, please.
So this point corresponds with this point. The y value is 9. Cut it in half, and I got a 4.5. All right, let's plug in -2. It's 1/2 times -2 squared. -2 squared is 4. 1/2 times 4 is 2. Okay, so plug in -2, and I get 2. Okay, notice that plugging -2 into the blue function is the same thing as plugging -2 into the black function and multiplying your y value by 1/2. So when I plug -2 into the black function, I got a 4. Y value is 4. Multiply 4 by 1/2, and I get a 2. All right, h of -1 is 1/2 times -1 squared. -1 squared is 1. 1/2 times 1 is 1/2. So plug in a -1, and I get 1/2. So notice this point corresponds with this point. The y value of the black point was 1. Cut that in half, and you get 1/2. Plug in 0. 0 squared is 0, so I end up with 0. The y value of the black point was 0. Half of 0 is still 0. H of 1. 1 squared is 1 times 1/2. I'll get a half. So the black point was 1, 1. Cut the y value in half, and I get 1/2. Plug in a 2. 2 squared is 4. Half of 4 is 2. So h of 2 is 2. Corresponds with the point 2, 4 on the original black graph. Cut the y value in half, and you get a 2. One last one, plug in a 3. 3 squared is 9. Half of that is 4.5. So I get this point. Corresponds with the point 3, 9. Half of 9 is 4.5, so I have the point 3, 4.5. Let's make a graph of that. So notice multiplying by 1/2 in front made the graph fatter and flatter. Okay. But the main thing to notice is that for every x value you plug in, the y value of the original graph gets cut in half to give you the point on the new graph. All right, let's look at another example. Again, I've got x squared graph for you. Let's do smiley of x is equal to -x squared. Okay, so as usual, let's plot some points and see what happens. So smiley of 0. So 0 squared is 0. -0 is still just 0. So I'll have this point. Plug in a 1. We'll have -1 squared. 1 squared is 1. Make that negative, and you get a -1. So if I plug in 1 I'm going to get -1. Notice that plugging plugging 1 into the blue graph, or the blue function, is the same thing as plugging 1 into the original black graph and then making my answer negative, or making the y value negative. So plugging 1 into the black graph, I get a 1, but I'm going to make the 1 negative. So I'll have -1. All right, let's try 2. -2 squared. 2 squared is 4, make it -4. So plugging 2 into Smiley is the same thing as plugging 2 into the original black graph and then making your answer negative. So when I plug 2 into the original black graph, I got 4, but now I'm going to make the 4 negative. 4, so I get -4, plug in 2, and I get that. So this point corresponds with this point, except the positive 4 becomes -4. Plug in a -1, that'll be exactly the same as plugging -1 into the original function and then making my answer negative. So -1 squared is 1, make it negative, -1. So plugging a -1 to the original, I got 1, but now I'm going to make that 1 negative, and I get that. I plug 2 in, -2 squared, that'll be -4. That's the same thing as plugging a -2 into the original function, getting 4, and then making my answer negative. So down here, and I get that. So, putting this negative sign in front of the x squared, or in front of the original function, causes the graph of the original function to flip across the x-axis. All right, so here's a really fun example. I've given you the graph of a function here. There's no equation for this function, it's just some random thing, but I have given you 1, 2, 3, 4, 5 points that I've labeled on it. Let's graph this new function. Okay, so our new function g, or the blue function, is going to be the original function plus 2. So f of x plus 2. All right, so let's see if we can graph this new function g, graph the blue function. So g of 3, or g of -3, should be f of -3 plus 2. So plugging -3 into the new function is the same thing as plugging -3 into the original function and then adding 2. So f of -3, well, I don't have an equation, but I do have this point labeled here. F of -3 was -2. So I've got -2 plus 2, which would be 0. So g of -3 should be 0. Let's do g of -1. So g of -1 will be f of -1 plus 2. So plugging -1 into the blue function is the same thing as plugging -1 into the original function and then adding 2. So f of -1, I don't have an equation, but I do have a graph. F of -1 was 0, and 0 plus 2 is 2. So I have that. G of 0, plugging 0 into the g function would be the same as plugging 0 into the original function and then adding 2. F of 0, again, I don't have an equation, but I can look at the graph. F of 0 was 1, 2, 3, was 4. So I get 4 plus 2, which is 6. 1, 2, 3, 4, 5, 6. I have that point. G of 1 would be the same thing as plugging 1 into the original function and then adding 2. F of 1 was 3. So I have 3 plus 2, which is 5. That's here. And one last point, g of 5. Same thing as plugging 5 into the original function, and then adding 2. F of 5 was 0. 0 plus 2 is 2. So notice what happened is that all these points got shifted up 2 spaces. So just like in our previous example where we had x squared plus 2, and x squared was the original function, that plus 2 out on the end shifted the whole thing up 2. So this graph, look like that. Yeah. So notice the black graph got shifted up 2 spaces. All right, let's do another really interesting example. So same f graph, same black graph. Let's graph this new function, f of x minus 2. All right, so let's plot some points. Let's do h of negative 1. So if I plug negative 1 into the h function, I'm going to put a negative 1 everywhere where I see an x. So I'll have f of negative 1 minus 2. Negative 1 minus 2 is negative 3. So I'm really doing f of negative 3. So plugging a negative 1 into our new function, into the blue function, is the same as plugging a negative 3 into the original function. So if I plug negative 3, 1, 2, 3, into the original function, I get a negative 2. So I plugged a negative 1 into our new function. That ends up being the same as plugging a negative 3 into the original function. So my answer would be negative 2. So if I plug negative 1 into the new function, my answer is negative 2. Okay, so again, plugging negative 1 into the new function is the same thing as plugging negative 3 into the old function. So this point gets shifted right 2 spaces. All right, let's do h of 1. So that would be f of 1 minus 2. 1 minus 2 is negative 1, so that's f of negative 1. So plugging a 1 into the blue function is the same thing as plugging a negative 1 into the black function. And so I'm plugging 1 into the new function, but that's the same thing as plugging negative 1 into the old function. F of negative 1 was 0, so I should get a 0 here. I plug in a 1, my answer is 0.
Ms. Sawyer, call 1634.
All right, let's do h of 2. So that will be f of 2 minus 2. That will be f of 0. F of 0 was 1, 2, 3, 4. So my answer is 4. Okay, so plugging a 2 into the new function is the same thing as plugging a 0 into the old function. If I plug a 0 into the old function, I get a 4. So if I plug a 2 into the new function, I'll get a 4. So this point got shifted right 2 spaces. Let's do h of 3. That'll be f of 3 minus 2, which will be f of 1. So plugging a 3 into the new function is the same thing as plugging a 1 into the old function. If I plugged a 1 into the old function, I get a 3. So plugging a 3 into the new function gives me a 3. So notice this point got shifted left, or shifted to the right 2 spaces. All right, h of 7. That'll be f of 7 minus 2, which will be f of 5. So plugging a 7 into the new function, 1, 2, 3, 4, 5, 6, 7. Plugging a 7 into the new function is the same thing as plugging a 5 into the old function. If I plug the 5 into the old function, I get a 0. So plugging 7 into the new function should give me a 0. Notice that point got shifted right 2 spaces. All right. This should be 3 here. I didn't write it down. All right, so let's make us a graph here. So notice every point on here got shifted right 2 spaces. So even the points I don't have labeled, we don't know what they are, but they would get shifted to the right 2 spaces. So my graph looks like that. That. So the whole black graph got shifted to the right 2 spots. All right, let's ask one more question here. H of 5. So I plug in a 5, I get f of 5 minus 2 is f of 3. Okay. So I'm going to look at the black graph. F of 3 should be this point right here. But I don't have that label. I don't have an equation, so I don't know for sure exactly what that point is. Kind of looks like it's a 2, but I really don't know that for sure. So I really can't answer this question. But I know that whatever this point is, it's going to get shifted right 2 spots, and it'll correspond with that point right there. So this is a question mark here. That doesn't look like one. All right, let's do another really fun example. Got your same original graph. J of x is equal to negative 1/2 times the original function. So let's do j of negative 3. That'll be negative 1/2 times f of negative 3. So in order to figure out what f of negative 3 is, I need to look at the original graph of f of x. F of negative 3 was negative 2. So I have negative 1/2 times negative 2. It'll be a positive 1. That didn't really go with that one. We can try that again. That's negative 1/2 times negative 2, which is 1. All right, now put this on the right line here. J of negative 1, that'll be negative 1/2 times f of negative 1. F of negative 1 was 0. So I have negative 1/2 times 0, which would be 0. So this point will stay right there. J of 0 is negative 1/2 times f of 0. F of 0 was 4. So negative 1/2 times 4 is negative 2. So that would go here. J of 1 would be negative 1/2 times f of 1. F of 1 was 3. So I have negative 1/2 times 3. Half of 3 is 1.5, so negative 1.5. That would go here. And J of 5 would be negative 1/2 times f of 5. If I plug a 5 into the original function, I get 0. So negative 1/2 times 0 is 0. So that point will stay the same. Okay, so like the original, or like an example a minute ago, when I multiply by a negative in front, it will flip the graph across the x-axis. Recall that multiplying by this half multiplied all the y values by 1/2. So this graph, if I flip it across the x-axis, will look like this, except it'll be slightly flatter. Go here, here. So notice that the original black graph was flipped across the x-axis, and it got sort of flattened out because of the multiplication by the factor of 1/2. Okay, so here's one for you guys to practice. You have f of x is equal to the absolute value of x. So the first thing I want you to do is graph the original function. And then I want you to graph this new function, p of x. Okay, so pause the video, work on that, then resume the video, and we will go over the solutions. Okay, so let's make a graph of absolute value of x. So if I plug in 0, I get 0. If I plug in 1, I get 1. 2, I get 2. 3, I get 3. 4, I get 4. 5, I get 5. If I plug in -1, absolute value of -1 is 1. -2, I get -2. -3, 3, -4, -4, -5, I get -5. So my graph looks like this. A nice V shape. All right, so now let's graph this new function. So we can always graph functions by plotting points. So let's plot some points. Let's do p of -5. Okay, so if I put -5 in here, I'll have -2 times the absolute value of -5 minus 1 is 3. Work that out. I have -2 times the absolute value of -6 plus 3. I'll have -2. Absolute value of -6 is 6 plus 3. -2 times 6 is -12 plus 3. And I get -9. So if I plug in -5, I should get a -9. I'm not going to plot that one, it's way down there somewhere. So let's do another one. -9. All right, let's try -4. P of -4. Okay, so if I plug in -4, -4 minus 1 is -5. Absolute value of -5 is 5 times -2 is -10. -10 plus 3 is -7. Okay, so I got 5, that would be down in this area somewhere. We'll go ahead and do that one. Grab 2 more. So there's -7. So if I plug in -4, I get -7. Now let's do -3. If I plug in -3 minus 1 is -4. Absolute value of -4 is 4. 4 times -2 is -8. -8 plus 3 is -5. So plug in -3, and I get -5. Let's do p of -2. So plug in a -2, get 3. -6 plus 3 is -3. You probably detect a pattern there. So plug in -2, I get -3. P of -1. So I plug in -1. -1 minus 1 is -2. Absolute value of -2 is 2. 2 times -2 is -4. Plus 3 is -1. My little pattern is continuing. That. And plug in 0, find the initial value. 0 minus 1 is -1. Absolute value of -1 is 1. 1 times -2 is -2. -2 plus 3 is 1. So P of 0 would be 1. So notice I'm going up 2 every time, so I got a straight line. Straight line looks like that, or as straight as I can make it. Let's do P of 1. 1 minus 1 is 0, so that's gone, so I get a 3. P of 1 is 3. So I'm still going. Alright, P of 2. 2 minus 1 is 1. Absolute value of 1 is 1. That's -2. So I get a 1. So I'm plugging in 2 and I'm going back down now. P of 3. 3 minus 1 is 2. Absolute value of 2 is 2 times negative 2 is negative 4. Plus 3 is negative 1. And you see what's happening then. I'm going to go down 2 every time. So if I plug in a 4, I would get a negative 3, and so on. So the graph looks like that. Okay, so let's notice some things about this function. First of all, inside of the absolute value, I had a minus 1. So sort of inside of those parentheses like the previous examples. The minus 1 inside took this original point and shifted it right 1 spot. So the minus 1 shifted it right 1. Okay. The negative 2 flips it across the x-axis and stretches it out. So notice the blue graph is stretched more, it's skinnier, it's been stretched vertically, and it's also upside down. So the minus or the negative flipped it, and the 2 stretched it vertically and multiplied all the y values by 2, or by negative 2. The plus 3 shifted it up 3. So this original point went right 2, or excuse me, went right 1 because of this. It got multiplied, or the y value got multiplied by negative 2. The y value was 0, so that didn't change. And then I shifted it up 3. Let's look at this black point. Okay, so this black point at 1, 1 got shifted right 1. The y value got multiplied by negative 2. So instead of 1, it would now be negative 2. And then it got shifted up 3. And there's my new point. Okay, let's take a look at this point, 2, 2. Okay, so this point, 2, 2, got shifted right 1. So it becomes 3, 2. The y value got multiplied by negative 2, so it became 3, negative 4. And then it got shifted up 3, so it became 4, negative 1, right there. Okay, let's take a look at one more point. Let's do the point 4, 4. Okay, so this point right here is 4, 4. Okay. This minus 1 will shift this point right 1. So if it goes right 1 space, this point will now be at 4, 5. No, that's not right. It'll be at 5, 4. Excuse me. It'll be at 5, 4. Okay. If I multiply the y value by negative 2, this point will now be down here at 5, negative 8. Then if I shift that point up 3, this point will then go to 5, negative 5, which would be right here. And we can check that if I plug 5 into this function. 5 minus 1 is 4, absolute value of 4 is 4. 4 times negative 2 is negative 8, plus 3 is negative 5. So that point is on there. So to review that, this minus 1 will take any point on the black graph and shift it right 1. The minus 2 will multiply the y value of that point by negative 2. And then the plus 3 will add 3 to the y value. So you can kind of trace each point on the black graph through all these transformations. It shifts it left or right. In this case, it goes right, multiplies the y value by negative 2, and then adds 3 to the y value. Okay, so to say that one more time. This minus 1 will take the original point on the graph, and it'll add 1 to the x value. It'll shift it to the right. This negative 2 will multiply the y value by negative 2. The plus 3 will multiply the y value, or will add 3 to the y value of each point. All right, so here's a really fun question for you to try. So if the point 3, negative 20 is on the graph of some function f, I want you to tell me what's a point on the graph of this new function g. So g of x is equal to 1/4 of f of x plus 2 minus 7. So I'm telling you a point on f. I want you to find me a point on the new function g. Okay, so pause the video, think about this, try to figure it out, and then resume the video and we will talk about the solution. All right, so maybe you racked your brain for a while on that and maybe you couldn't come up with an answer. I'm going to give you a hint this time. So let's put this on a graph. Okay, so I know that the point 3, -20 is on the graph of f, but that's all I know about f. Okay, so it could look like anything, I don't know, maybe like that. Who knows what it looks like. All I know is that this point 3, -20 is on the graph of f. Okay. So now, just like on the previous example, think about all the things that are happening, what this 1/4 will do to the graph of f, what the +2 will do, and what the -7 will do. So just like we did on the previous example, trace that point around the graph and see where it ends up at. So if you didn't get an answer the first time, think about this hint I've given you. Pause the video and see if you can figure it out now. Okay, so maybe you got it now, maybe you didn't. If you didn't get it, I'm going to give you another hint. Okay, so my new hint is I want you to try to find g of 1. So tell me what g of 1 is, and that should answer the question. So pause the video, work that out, and see what you get. All right, so let's go with this hint right here first and see if we can figure it out. Okay, so I know the point 3, -20. So what will this new function do? The +2 inside the parentheses should shift this point left 2 spots. So from 3, -20, I'm going to go to 1, -20. So it'll be here, 1, -20. Okay. The 1/4 will multiply the y value by 1/4. So instead of 1, -20, I'm going to have the point 1, -5. Okay. The -7 will shift that point down 7. So instead of 1, -5, I'm going to have the point 1, -7 after it goes down. Or excuse me, it's going to go down 7, so I'll have the point 1, -12 right there. So I think that the point 1, -12 should be on the graph. So there's 1, so 1, -12. Okay, so to review what we just did there, I took this original point 3, -20. I shifted it left 2, so it became 1, -20. I multiplied the y value by 1/4, so 1, -20 became 1, -5. I shifted 1, -5 down 7, and it became 1, -12. Okay, so notice I've got the 1 for my x value. That corresponds with the hint I gave you over here to find g of 1. So if you find g of 1, you've got 1/4 times f of 1 plus 2 minus 7. 1 plus 2 is 3, so I got 1/4 times f of 3 minus 7. F of 3, I told you what it was -20. So when I'm about out of room, I've got 1/4 times -20 minus 7. 1/4 times -20 is -5 minus 7, and I get -12. So g of 1 is equal to -12, and the point 1, -12 would be a point on the graph of g. So the answer is 1, -12. And that's the only point that we know for sure can be on g. All right, last practice problem here. I've given you a graph of f, no equation for it, just some random graph. I have shown you 1, 2, 3, 4, 5 points on there though. Here's a new function g that has f in it. It's related to f. I want you to make me a graph of this new function g. So pause the video, work that out, and we'll go over the solutions. Okay, so let's take each one of these points and see if we can move it around. So this point, -4, -2. I know that the +1 will shift it left one spot. So I know that I can find the point g of -5. Okay, because I know that point's going to get shifted left 1. Okay, so if I put a -5 in for x, I get that. So I've got -2 times f of -4 minus 3. So to be clear, I used -5 for x because that allowed me, when I put -5 in, to find f of -4. -4 is a next value that I know how to plug in. So I had to choose really carefully what number I could plug in for x. I couldn't just plug in any number because I only know 5 points. All right, so continue working this out. I have -2 times f of -4 would be -2. -2 times -2 is 4. 4 minus 3 is 1. So if I plug in -5 to the new function, I get a 1 out of it. Okay, let's try another. Let's consider this point. My x value is -1. I know I need to shift to the left 1. So I'm going to try g of -2. So that was 1. All right, so if I put a -2 in for x, -2 plus 1 is -1. F of -1 is 0. -2 times 0 is 0. 0 minus 3 is -3. So I plug in a -2 and I get a -3. All right, let's take this point. This point's going to get shifted left 1. So I know that I can find g of -1. Okay, so plug -1 in for x. -1 plus 1 is 0. F of 0 is 2. -2 times 2 is -4. -4 minus 3 is -7. G of -1 is -7. 1, 2, 3, 4, 6, 7. And -1, and I got a -7. All right, let's consider this point. So I'm at 2 on the x. I know I'm going to shift it left 1. So I should be able to plug in a 1 to my g function. If I plug in 1, 1 plus 1 is 2. F of 2 is -3. -2 times -3 is 6. 6 minus 3 is 3. So I get 1, 3. All right, and the last point that I can do, the x is 1, 2, 3, 4. So if I plug 4, or I know that point's going to get shifted left 1, so I can plug in a 3. G of 3. 3 plus 1 is 4. F of 4 is 0. 0 times -2 is 0. And I get -3. So G of 3 is -3. All right, so I found all 5 points that I can find. Notice that this is a negative in front, so this graph gets flipped around the x-axis. So what does this thing look like? Let's see. All right, so I made a mistake on here. Hopefully you all caught it as I was doing it and you were yelling and screaming at me to fix my mistake. Good thing about math is You can catch your mistakes if you pay attention. So I started to graph this and I realized this didn't make any sense. If this part right here, if I flip across the x-axis, it should be going down this way. And I noticed that I had a point right here and I got really scared and I paused the video real quick so I could figure out what I did wrong. But now I see the stupid mistake that I made right here. This point is not -4, -2. This point is -4, 2. That's pretty silly. So this is not right. If I put -5 into this equation, I get -5 plus 1 is -4. F of -4 is 2, not -2. And then -2 times 2 is -4. -4 minus 3 is -7. So this point should be at -7. Now we can make a graph that looks like it should. This goes this way. And then I have this, and that. And that looks a little bit better now.